In the previous class, we have completed chemical kinetics topic as well as level 1, level 2, level 3 objective type questions, right? So now we are going to discuss some previous year questions, PYQs of this chemical kinetics. Okay. So in this, the first question is A to B, A given B. Okay. So the molecule A changes into its isomeric form B by following a first order kinetics. Okay, so by following first order kinetics, molecule A changes into its isomeric form B at a temperature of 1000 kelvins. So temperature is given, and if the energy barrier with respect to reactant energy for such isomeric transformation is 191.48 kilojoules per mole and the frequency factor is 10 to the power of 20. The time required for 50% molecules of A to become B is dash picoseconds. So here the time required for 50% of molecules of A converted to B is called half-life, right? T half. So now he given information and he is asking to calculate half-life time, that is T half. Okay. So first write the given data, that is temperature. Temperature is how much? Temperature is equals to 1000 kelvins, right? So 1000 K. If the energy barrier with respect to a reactant energy for such isomeric transformation is, so here energy barrier with respect to reactant energy, that means he is given activation energy. Okay, so EA is equals to how much? 191.48 kilojoules per mole. Okay, and the frequency factor. So what is the frequency factor? Frequency factor is denoted by A, that is equals to how much? 10 power 20. Okay, next, so he is asking to calculate the time required for 50% molecule of A to become B, that is T half is equals to how much? So we know the formula to calculate T half for first order reaction. He mentioned it is the first order reaction. For first order reaction, what is the T half? T half is equals to 0.693 divided by K, right? So to calculate T half, we must know K. So what is K for first order reaction? K is equals to 2.303 by T log concentration of A by AT. But he has not given that information here. He given temperature, activation energy and A. So in the terms of the given data, we need to take another formula. What is that? K is equals to A into e to the power of minus EA by RT. So by using this formula, we need to calculate K. Okay. Now substitute that values here. K is equals to A. What is A? 10 to the power of 20 into e to the power of minus 191.48, and he is given kilojoules. We must take the value in joules. So convert kilojoules into joules. So 1 kilojoule equals to 1000 joules. So we can write 1000 as 10 to the power of 3, right? Next, R value. What is R? Gas constant. He given R value. How much? 8.314. So 8.314 into T. Temperature is how much? 1000. So 1000 means 10 to the power of 3, right? So cancel this 1000 and 10 to the power of 3. So now minus 191.48 by 8.314. So here if you take this, we will get very less value. So now proceed the formula calculations by considering this value is very less. Okay. So that is equals to 10 to the power of minus 10. So here 10 to the power of minus 10 will be equals to 10 to the power of 20 by, so K is equals to 10 to the power of 20 by 10 to the power of 10. Okay. So now 10 to the power of 20 by 10 to the power of 10. So that is equals to how much? 10 to the power of 10. So K value is equals to 10 to the power of 10 mole per liter, right? Next, so substitute this K value in this T half. So T half is equals to how much? So T half is equals to 0.693 divided by K, right? So now substitute K value here. T half is equals to 0.693 divided by here 10 to the power of 10. It is approximately equal to 10 to the power of 10. So T half is equals to 0.693 by 10 to the power of 10. It becomes 0.693 into 10 to the power of minus 10. Okay, so what is the half-life? 0.693 into 10 to the power of minus 10 seconds. But what he is asking, A to become B is dash in picoseconds. In picosecond, 1 picosecond is equals to 10 to the power of minus 12 seconds. Okay, so here 10 to the power of minus 10. Now convert this into the 10 to the power of minus 12. How? If you move this point 2 digits right side, 69.3. Now here the power will decrease 2 times. Okay, so 10 to the power of minus 12. 10 to the power of minus 12 seconds. So here 10 to the power of minus 12 second is equals to 1 picosecond. Therefore 69. So T half is equals to B60 in nearest integer. He asked for nearest integer. So that is 69 picoseconds. Okay, picoseconds. So what is the answer here? 69. Okay. So answer 69. First write the given data and use this formula. K is equals to A into e to the power of minus EA by RT. Okay. So minus EA by RT. And here this value will get very less, that is equals to 10 to the power of minus 10. So it becomes 10 to the power of 20 divided by 10 to the power of 10. Okay. So here we are getting K is approximately equals to 10 to the power of 10. Now substitute this value in T half formula, that is 0.693 divided by K. So K 10 to the power of 10. Now he is asking in picoseconds. Here 1 picosecond is equals to 10 to the power of minus 12 seconds. So now convert this into the 10 to the power of minus 12 form. How? By moving this point to the right hand side. So 69.3 into 10 to the power of minus 12 seconds. 10 to the power of minus 12 is equals to 1 picosecond. So 69.3 picoseconds. And he is asking nearest integer. So for 69.3, which is nearest integer? 69. So 69 picoseconds. Okay. So what is the answer? 69. Next question.